Yeah. Hello, welcome everybody to my talk about integration testing with Docker and test containers. I'm super happy to be here today at DevOps, directly removing the screen. All right, and I try my very best to follow up after this very entertaining talk by Venkat, and I hope this talk will also be entertaining for you. Yeah, a little bit about myself at first. My name is Kevin Wittek, it's Twitter. I'm currently working as a software engineer at CodeCentric. It's a German consulting company. And actually next month I'm going to start my PhD, so I'm going back to academia and let's see how this turns out. And also I'm like a self-employed consultant at my own company. I've founded back in university, Styracosoft. And I'm one of the core maintainers of the Testcontainers project, and in general a big fan of all kinds open source, free and open source software. And yeah, in addition I'm also Oracle Groundbreaker ambassador, and I'm organizing the local software craftsmanship meetup in the Ruhrgebiet area where I am from. Before we go into the topic, maybe a quick show of hands. Who here already knows test containers? Some, yeah. And who of you are using test containers actively already? Some, that's pretty cool. And who here knows Docker? So basically everybody. All right, cool. So let's start with a little story at the beginning. Why do we test? Why do we want to test? Or maybe why do we want to do integration tests? And this is now inspired by something which just recently happened to me in my project. So we want to test because we don't want to end up here. And what do I mean in this case? So I'm currently working on a project where we are writing a management software for dairy farms, for milking farms, that's also controlling the milking and feeding of the cows. So, and what happened in one case, in one test installation, there was a bug in the software basically, in one of the SQL queries, and the result of this was that the farmer was calling us one day and saying, oh, my food is suddenly empty, what happened? The cows are getting too much food. And then we found out, oh yeah, there was a bug in the SQL query, the food the cow was supposed to get was calculated in the wrong fashion, and then we had to like build an update, and we had to drive out there to the farm and install the update, and I was literally standing in the cow shit updating a Wildfly server there, and it was also really smelling like cow shit everywhere. That was a pretty intense experience, but I don't necessarily have to repeat this. And we could have found this bug with better integration testing right there. But mock unit testing would not have helped because we had this in place. So the key learnings I want to provide to you as part of this talk is that nowadays, with the tooling available, it's quite easy to set up complete test environments, test and development environments that are described as part of our project repository. And if we are able to do this, then there is not that much effort needed anymore to write integration tests against real external application, against real external dependencies. And therefore, we also want to avoid integrated tests. In a little bit later, I will talk about what are integrated tests. And that's like the goal I have, or maybe we all should have, the development community, that if someone joins a new project, he should be able to just clone the project, run the build in Gradle, Maven, or whatever language, and it should just work. It should run unit tests, integration tests, it should build stuff, it should download the dependencies, it should set up test database, whatever. And yeah, I think it's possible nowadays if we work on it, and maybe like the stuff I'm going to show today is one step in this direction. So, classical testing pyramid, most of you will know this. It's shaped like a pyramid, and we have mostly unit tests at the bottom, then some integration tests in the middle, and there are different names for these sometimes. Some people also distinguish between component tests or service tests or API tests. And then normally we have some automated UI tests at the top, maybe something like Selenium browser tests, and sometimes people call those end-to-end tests or functional tests or acceptance tests. But actually the definitions are not that clear always in this regard. But yeah, I think we all have kind of this mental model when we think about a testing pyramid. And so we wanted today focus on integration testing, and what would I consider integration testing, also for the talk. That's all tests that interact with external systems. or external dependencies. So if I'm having just two classes in Java and they're interacting with each other without any external stuff, I would call this a unit test. But some people would argue differently, but I would call this a unit test. So I would call an integration test all this classic stuff, something interacting with the framework or the application server or with the file system network, with a database, whatsoever. That's an integration test in my book. Yeah, so, but why is it a pyramid? Why have we chosen to say a pyramid is a good shape to organize our test suite? And yeah, there are probably a lot of historic reasons for this, and the historic context might be there that it's just like too expensive to too expensive to run those integration tests. They are maybe too slow, they are too brittle, they are flaky, whatever. We want to concentrate on the unit tests that we can control in a good fashion. And maybe nowadays those reasons are not that true as it used to be anymore. Like at least other companies and other teams come to this conclusion. That's why we are seeing increasingly newer shapes of the test pyramids that are employed for some teams. For example, this is the one that Spotify uses. They have a blog post about it, and they call it the testing honeycomb. There are other examples. Logs.io, for example, they use something called the testing diamond, which is very similar shaped. And here we have a button of implementation detail. That's what we would consider unit tests in the classical test pyramid. Then we have a big block of integration tests, and then we have some integrated tests. Who here has an idea what an integrated test means? Yeah, I think it's a very obscure definition, but it's a pretty good one. That's why I will define it in the next slides. So let's ignore those integrated tests for a moment. But what they say in the blog post, why they use this shape, they say they have a very microservice heavy architecture, so a lot of microservices, and it's just better for them to write kind of black boxy integration tests, so they can easily replace the microservices or big part of the microservice code instead of having like white box mock stub tests where they really have to stub certain stuff, and this will break if they do extreme refactorings. And they say the integration test there, they give them just more flexibility, agility, one could say, to have extremer refactorings. And it might make sense if you think about it from a microservice perspective, like the amount of code in a microservice that is responsible for the integration stuff is in relation to the business code, in general, bigger than in a monolith. So in a monolith, you have, of course, the integration surface, but also a lot of business stuff inside. And in the microservice, you have maybe the same surface size, integration surface size, maybe a bit smaller, but the business code in relation is smaller, one could argue. And that could be a reason why they say this is a good pattern for them. So, but now integrated tests, what is this, and yeah, why they chose to display it here. By the way, they say integrated tests, they have some, but it's an anti-pattern. They want to avoid them. So what are integrated tests? In the blog post, they reference another blog post by J.B. Rainsberger from the software craftsmanship community, or a big test-driven development advocate. And he says, I use the term integrated test to mean any test whose result, pass or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior. So pretty extensive definition here, and Spotify just say a test will pass or fail based on the correctness of another system. So we don't want to have those. They are an anti-pattern. And what are examples for those integrated tests? For example, if we manually spin up other services in a local testing environment, you have to start your local database, or you have it to have installed to run your test locally. We don't want to have this. Or even worse, I would say, if we test against other services in a shared testing environment. For example, we have a host database system, like a shared big DB2 instance that all teams or all developers use and share, and sometimes you are testing new changes to the database, maybe to the database schema, and your changes there will break the test of the other people, or the other way around. But also at the same time, if you change just your system, and this will break tests for other teams, that's also an integrated test that you want to avoid. For example, all the teams or all the developers are just always deploying in a shared testing environment, and all services are tested there together, and you're introducing an API breaking change, and then you will suddenly let the test of the other team fail, although they didn't change anything. And those kind of stuff, it's confusing. We want to avoid this because it doesn't help us in really pinpointing down what led to a failing build, for example. All right, so and which tools do we use in the JVM world and beyond to come to a state where we can avoid those integrated tests but have really nice integration tests? Yeah, basically we can use most of the tools we're already using, like our normal Java testing stack is well suited for this, but just for fun I'm showing also Groovy as a testing framework or Spock as a testing framework in Groovy and so on. But yeah, all the stuff I'm showing you can completely in the same fashion apply to Java with JUnit 4 or JUnit 5 or whatever. But another core component is of course Docker, as you might have inferred from the title of the talk. Docker in conjunction with test containers. So yeah, Docker, I'm skipping the part where I'm explaining what is Docker. So we're using Docker to instantiate containers, our external dependencies as containers, as small throwaway instances of those services. And yeah, most of you know Docker. So for the others, I would just recommend that you look up and get a basic understanding of Docker after the conference, maybe. All right, so why do we want now to combine Docker with our JVM testing world, our JVM testing framework like JUnit? Yeah, like I said in the introduction, easy setup of the development environment, and therefore, I mean, like for me, I'm a big fan of test-driven development, and I think one is also able to apply this test-driven development approach to integration tests, and therefore I need those integration tests locally so I can do my development. So it's not just for testing, it's also for my development, so I get really fast feedback. If I have to push something into the pipeline and have to wait 1 minute, 2 minutes until I get feedback, I think that's too slow. Also, we want to have a uniform build and test environment. I want to be pretty sure that if the build and the tests work and run on my system, they should run and work the same way on the CI system. And therefore, everything should be self-contained in the repository, in the tests, as part of the tests, and should be executed the same way in the other environments as well. And yeah, in addition, I don't want to install any, I don't want to have any manual installation and setup of external software like databases, like a Kafka or whatever. But of course, if we start to use Docker for this stuff, we need Docker somewhere. Yeah, and how do we combine now Docker and the JVM? We use test containers. All right. So let's start. What is test containers? Let's start by looking at some example code, how you would use test containers. So we can use test containers to start Docker containers from Java. And here we see it's just as easy as instantiating a class, generic container in this case. You provide the image name for which you want to start a container. You're saying, okay, I want to interact with this container on this port. Then you say ready start, and then it starts. And the neat feature of test containers is that it will block at this point until the application inside the container is started, one could say, and then you can just stop it. So you have an object-oriented abstraction over Docker containers, and that's pretty neat. So let's go a step back and have an overview about the project in general. So Test Containers Java was first released in 2015 by Richard North, who's also in the audience. And it was released in Japan, how I learned 2 days ago. And it's 100 open source software. It's under MIT license. It's on GitHub. And so far we have 65 releases and already 149 contributors, which we are very happy about. And we currently have for the Test Containers Java project 3 core maintainers, Richard obviously. Then we have Sergey Ogorov and myself. Who joined as the last person. And we're also getting increasingly more support for other languages by basically having re-implementations or forks in those languages that follow the same paradigms and ideas. So we already have implementations in Python, C#, Rust, Go, JavaScript, a Scala wrapper, and yeah, they are not all as feature complete as the Java version, but they are going there and they are getting used. For example, the Go version is used in quite a lot of projects nowadays, open source projects. Yeah, so what you can do with test containers? So there are a lot of different features. The small code snippet I just showed you is the most simple manual interaction to starting a container, and that's a generic Docker container support, where you can basically just use any image you want. You just specify it, then test containers will start it as a Docker container, and it will clean up afterwards. And you can use something like a Redis, MongoDB, or you can also use your own images that you are building as part of your CI or whatever. And therefore, you can also do black box testing of your containers, of your images with test containers. But we also have some special support for certain kinds of containers or images, image categories. For example, databases, for a lot of different databases, like relational databases, of course, something like a Postgres, but also many NoSQL databases like Cassandra or InfluxDB and so on. And some special support, or more sophisticated support even, for stream processing applications like Kafka or Apache Pulsar. And in addition, we also have support for AWS mocks, the local stack stuff. Of course, this is not like the real integration test against AWS, but it's probably as close as you can get locally without using those real dependencies. Then we support Docker Compose. You can just use your normal Docker Compose files you maybe already have in place for those local integration testing or integrated tests where you would maybe run this file beforehand. Now you can just point test containers to the Docker Compose file and it will start up the Docker Compose. And some pretty nifty stuff about Selenium, Selenium browser support, where the browser will run inside a Docker container. And also some chaos testing support for when you want to disconnect the network connection to a container and check, okay, does my application reconnect when the network reappears and so on. And yeah, so this is like the big overview stuff, and now some of the more technical stuff, what test containers allows. It's not really a feature of test containers, it's more a feature of Docker. But it's dynamic port binding that when you use test containers, you are basically able to bind the port of like the Postgres or whatever to any free ephemeral port of your system, so you don't get any problems of like an integrated test kind of class, so where you could not start the container since the port is already in use. So the general approach is just bind to a dynamically bind to a free port, and then Test Containers provides an API so you can get the actual port there, and different kind of wait strategies. So this is like a real important feature, and most people don't think about this when they first start to maybe use their self-built solutions to use Docker containers for testing. So when you're running a Docker container, let's for example say we are running a Postgres Docker container run. So what's happening, if you do this command, basically the container is created instantly after some milliseconds, but not the application inside the container. It takes quite a long time until the application actually is healthy, is up. And those wait strategies from test containers, they just block the start call until the application inside the container is really available. And normally you want this in your tests. You want your dependencies to be there and ready and healthy, so you can test against them in a defined manner. And we support all kinds of wait strategies there, just checking is a port available, do we get a certain HTTP response, log message, JDBC response, whatsoever. Yeah, we try very hard to discover out-of-the-box plug-and-play like any Docker environment we are running in with test containers. So normally you don't have to configure anything, and test containers will just infer from the environment how it has to interact with Docker. So therefore, we are also nicely platform independent nowadays and support all Docker versions, or most of the Docker versions on all operating systems. Linux, Mac OS with Docker for Mac, Windows 10 with Docker for Windows. And 2 days ago in the workshop, I realized we also have a little bit of support still for Docker Toolbox if you're running Windows 7, but we don't actively support this. All right, yeah, so works on Windows 2. It was quite a bit of work involved there to get it working on Windows because Docker for Windows is kind of different beast. Yeah, we are compatible with JDK 12 and regularly build against the OpenJDK early access version. We're not using the module system yet, but I don't know, maybe this will come at one point. Just kind of a promotional slide to show you some of the happy Testcontainers users. So we already have some pretty big companies using it and also some nice open source projects like, for example, Spring Data or Apache Camel here, Neo4j, a lot of companies here. And then you saw in the first code example how you could manually interact with a container, just like start it and have an object there. But we also have support for different test frameworks in the JVM. Like here you can see the JUnit 4 support that just works with JUnit rules. So if you annotate your container with that class rule, it will start the container for all the tests in a class and then stop it afterwards automatically for you or add rule for each test method. Then we have also a Spock extension for the Spock testing framework. And yeah, it's a similar idea. You're, in this case, just defining your class. You're adding the Spock extension to your test class. And then the Spock extension will automatically collect all the containers that have been defined as fields of your test and start and stop them accordingly. And since some time, we also have first-class support for JUnit 5, JUnit Jupyter. And the integration is a bit similar to the Spock one, so you're annotating your JUnit 5 test with the Testcontainers extension there, and then you can annotate every container for which you want the lifecycle to be managed by the extension with add_container. And it also works for nested tests and so on. All right, so enough talking for now. Let's show some demos. All right. Yes. So if you want to get started with test containers, you can just add the dependency into your Maven or into your Gradle build. Here I'm having a Gradle build. And I just added this BOM here, bill of materials, but you can also just add the dependencies directly. What the BOM does for test containers is just if you're using different test containers modules, so those specialized containers, we publish them in different modules. And if you're using the BOM, you don't need to define the version here again for like the Postgres or the Kafka Spock. So I'm integrating here, so I'm using those three models, Postgres, Kafka, and Spock. All right, so let's look at the example application. It's like as easy as it gets, bookstore-ish or whatever. So we just have one DTO or something we want to save in a database. It's a book, it has just two fields, name and author. And then we have a book repository, and it's all vanilla Java. So we have here a Java SQL connection, which we will use to save the book into a database, a relational database we're accessing using JDBC. And we have different methods here, save, count, or searching by author. And yeah, the actual implementation of these production stuff is not important here. And to make stuff even more fancy, we have some integration against Kafka, where in case we have a special offer for a book, we want to send out a notification onto some Kafka topic. And that's happening here in the send notification method. We're just having a Kafka producer to send some topics there. All right, so let's first look into the really easiest way how to integrate test containers for replacing a JDBC dependency. And that's possible by using a magic JDBC URL, and it looks like this. So we are having nearly the normal JDBC URL we would have for our Postgres, but we are also defining this TC here. So this will then use a special test containers JDBC driver, and this driver is responsible for already starting a container, the corresponding database container, and then proxying to the real driver. And all you have to do in your existing code base, like Spring Boot or JEE, doesn't matter. If you want to use test containers with real databases instead of maybe an H2, just use this special JDBC URL and you're good to go. And there are different variants, so you could also replace this Postgres with MySQL or whatever, then it would start a MySQL database. And the test here, it's a Spock test, so Groovy Spock, but it's like nothing Groovy or Spock specific. All I'm showing you can do the same way in JUnit or whatever. And in this test, we will at first check the repository is empty, we can save a book, then we have one book in there. We can also save a couple of books, then we can find them there, we can search and find them. All right, I'm using here Flyway to set up the initial database schema. And yeah, let's just check what happens when I run this. All right, we already see in the logs some Docker-specific stuff. We have this whale emoji here. So what's happening here, first, Testcontainers is checking that the environment in which this is running has like a working Docker, basically. It's like some constraint is enough free disk space and so on. Just the idea is to fail very early so the user knows, okay, something is wrong with my Docker setup here or my Testcontainers integration with Docker. And then we see that a container is created for Postgres, it started, and then Flyway runs and the test runs and so on and so on. That's all. So there are two modes how you can use this JDBC URL. One is a daemon mode, one is a regular mode. I'm here using the daemon mode. Daemon mode means it will basically bind the lifecycle of the container to the lifecycle of the JVM process. If we would omit this query parameter, daemon mode, it would keep the container alive as long as there is a connection. But since we have so super simple Java code here, like with no JDBC connection pooling or whatever, if I would omit this, let's just omit this and see what happens. All right, it's failing, and all tests will fail now. And if we look into the logs, we already see why it fails. It's now first creating a container, then it's applying the Flyway migration to initialize the schema, but then it's again creating a container. Why is it doing it? Yeah, because if we don't have any connection open anymore after the Flyway migration has been run, then it will just shut down the container. And then if our production code requests a connection again to this JDBC URL, we get a new fresh container instance. So that's something to keep in mind. But if you're using already some kind of like real framework, like Spring Boot or something, Jakarta, JEE, then you normally don't have this problem since they always will use something like JDBC connection pooling. So this is like the super easy example, how you can really transparently integrate this into your existing code, like just put it in your application properties in case of Spring Boot or whatever. But depending on what you want to do, you can also just work with it like with the object class, with the Postgres container class. And here I'm using the Testcontainers extension for Spock. And here I'm defining the container as a field of my test class. And here we see we can then interact with it in the test. Like we get some convenient methods like get JDBC URL and so on and so on. So we can maybe just check in the debugger what happens at this point. So again, basically the same thing. The container is getting started by the Testcontainers Spock extension in this case. Now we have the debugger here, and what I wanted to do, I just wanted to check. Let's just check this. All right. So we already get this convenient URL to which we can already connect, and here we see this ephemeral port that has been bound to. Yeah, and that's just so you can run tests in parallel and whatever. You don't have to make any assumptions over the system, that the port is really free. So that's an important feature to keep in mind. Yeah, and if we check at the console, oh, wait. what actually happened. So there's still the old Postgres running that I started for demo purposes before. All right. So we see the Postgres now running, the Postgres that has been started by Testcontainers, and we also see another container running. And I think it's a good idea that I quickly explain what this is about, because some first-time users, they are really wondering what's happening there. Why is this strange Rio container also started by Testcontainers? This Rio container is used to clean up the test resources, the Testcontainers resources after the tests and after the JVM exit. So basically, this container is responsible for removing the Postgres container and also other possible resources that might have been created, like volumes or networks or whatever. And we used to have this feature in the JVM itself, in a thread in the JVM, and it was working pretty okay-ish, but since we would trigger it with a shutdown hook, it would sometimes not be able to really clean up everything, because if you are submitting a Zipkin command to the JVM processes, then the shutdown hook would not be executed, and then you would end up with those dangling zombie containers. And that's something that we can easily provoke the Zipkin by just pressing the pause here, I think. Or maybe not. Normally, if you have something that's longer running, you press the pause button, then the button switches to the skull icon in IntelliJ, and then if you press the skull, it sends the Zipkin. Yeah, but in this case, the containers would be dangling there, and you could have this behavior often if you would do debugging or if you would run on a CI somewhere, and if the CI job would get canceled, it would normally Zipkin the build process. And therefore, we decided to remove this feature out of the JVM, and yeah, you can basically solve every problem by just adding another Docker container we found out, and we moved this into the Docker sidecar container here. All right, and we also see now everything is gone. Okay, so this stuff was pretty simple so far, but we also have the Kafka one that's a bit more complex. In this case, I say, okay, I want to have a Kafka container. And here again, I have a special method on it, get bootstrap servers. And that's the same like the JDBC stuff. It just gives you the URL where your application can connect to directly based on the dynamic port mapping and so on. And yeah, you somehow need to inject this into your system under test. If you build the stuff yourself, you can normally just use something like put it in the constructor or whatever. If you're using something like Spring or JWE, you have to think more carefully about how to interact with the framework so that you can go directly into the point of the life cycle of the test and the framework, so you can inject those values at the right time. All right, let's run this. Okay, and we again see some stuff happening. A helper container here started, that's part of the Kafka container implementation, and then the actual Kafka is started. When we look here, we see it running. So we had 3 containers running, again the Rio container, the actual Kafka, and this helper container that helps us in proxying the port of the Kafka. And why is it so? That's a bit more complicated reason. It has to do with Zookeeper, and that Zookeeper doesn't like nutting too much. So, and yeah, it's green, and everything is clean afterwards, and I think it's pretty cool. And if we check the test, so it of course takes some time. This takes like now 15 seconds, and that's not super fast. That's not super fast as a real unit test or as a stubbing unit test. But if you consider that is really like starting up an empty Kafka and also tearing down everything afterwards, and you're really working with a clean state here, you don't have to do anything, I think it's still pretty cool and pretty fast. But it's a trade-off. So you have to think about that your whole test suite doesn't get too slow, and that you come up with strategies to reuse containers and so on. So it's probably not a good idea to have this pattern where you will start up a new container for every test method. So one can do this, and sometimes it's very convenient because you can be sure that the container is super clean afterwards, but it gets a bit too slow, depending on your test suite and depending on what you're after. All right, so this is like the most basic example, and online you can also find other examples, I will publish, I will show the link afterwards in the slides, how to integrate with Spring Boot and so on. There's a little bit more work involved, but it all works with the same idea in mind. All right, let's come to another example. So now what we did was kind of a white box integration testing. From inside our application, we instantiated our class and saw how or checked how our class would interact with those external systems. Now we want to do a real black box testing of our whole system. And a system consisting of multiple microservices, and it looks like this. It's the voting application from the DockerCon some years ago. And the cool thing, what we're seeing here now, that the applications we're testing, the microservices, are not even Java applications or JVM applications. It's completely different languages, but still we will use Testcontainers Java to do the testing. And yeah, that's the microservice system that we're going to start with the Docker Compose. And that's basically the Docker Compose file. So the vote front end, the Redis backend, and so on and so on. The details are not that important, but I will show you how it looks when it's running. All right. All right, probably already running now. Localhost 5000. All right, so here's a voting front end. One can vote, and then we have here the result backend. So, and now we want to make like a full end-to-end test of this whole system. And if we check what is running here at the moment, quite some systems are running. And we want to do a test of this. And what we will do, we want to do a Selenium test with a browser, just like navigate, do the clicking like what we did here now, and see if everything behaves correctly. And yeah, again, we're using Spock for this, Spock with JEP. That I'm using Spock and JEP now is not important for the point of my example. It's just cool. It's just a cool, groovy framework for or library for writing really nice Selenium tests. And what our test will do, it will first go to the vote website. By the way, I have some sleeps in here. They are just there so that we will see in the end what's happening and not everything is too fast. So we go first to the vote page. We check that we have the text there as we expect. And at the beginning, the result is 50-50. And then we again to the voting page. We are voting for Groovy, obviously. And then we are seeing that the result is 100%. So that's what's happening here. And yeah, as I said before, we have support for Docker Compose. So it's called Docker Compose container here. And you can then just specify the Docker Compose file you want to use. And then Testcontainers will get everything up. Then we have another special container class here, browser WebDriver container. That's a container that contains the browser and a Selenium WebDriver. And it will also, as indicated by this, it will also expose its X server, like its rendered image using VNC. And then we are also starting a VNC Sidekick container to record the actual session, and then you have a video recording of what happened in the container. Yeah, and so the browser container, it's nothing specially from us. It's a container that's provided by Selenium, and it's rendering its graphics into a virtual frame buffer. Therefore, it's running kind of headless, but you can still access the rendered image. So that's pretty cool. And just for the fun of it, let's run it on a server in the Oracle Cloud here. If I would have still the connection, let me check. All right. So I could run this the same now locally, but just to show you, you can also run it on a server that's completely headless, so there's no X installed here, no browser, no whatsoever. All right, now we're in the same project here. All right, I'm running the tests. And yeah, we see see it starting. We see some scary error messages appear, and those can be ignored. That's some strange behavior from Docker Compose right there. And it's starting the whole system here, still starting the containers up. So here we see something, what I did, like VNC secret, localhost, blah, 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 blah. That's another nice thing. So you can, what I did here in my code, I would get the VNC address of the Chrome container after it has been started and just print it there. So you can also like interactively debug it. Just make a breakpoint somewhere, then you can connect into the container using a VNC client of your choice, and you can check what's happening there. All right, so build successful, this executed. And it also downloaded, or it also created a video image. Test result? Yeah. So I'm just starting a Docker container there real quick to have an HTTP access to the server, so I can download it. All right, so you see I run this test a couple of times already, and this is a recent one from now. All right. And that what was happening inside the container on the server, and yeah, I think works as expected. And you can just check out this project and you can run it locally or wherever you want, and it should produce the same results for you if you have Docker installed on your system. All right. That's this. Yeah, this was a demo, we already did this. All right, CI inside the containers, like what happens if my CI process is already running in a container? Can I still use test containers? Long story short, yes, you can do, but then you have to know what you are doing. So there are different strategies of running Docker from inside a container, and in a nutshell, you can either use Docker in Docker, which has advantages but many drawbacks, or you can also use something called Docker wormhole pattern, where you would have a setup like this. So this is your build container here, and it's mounting the Docker socket from your host, and then the Docker client inside your build container will interact with a Docker daemon running on your host. And that's perfectly fine for most scenarios, but what will happen in this case is that all containers you are starting from inside your build container will be sibling containers instead of child containers. And that's just something you have to be aware of. So it, for example, means that the spawned containers, the sibling containers, won't have, in an easy manner, access to the file system inside of your build container, at least not with the normal volume host mounting you might be used to in Docker. So yeah, in general it works, and we also test it with most of the CI systems and CI systems available there. But at this point, you have to know what you're doing and how you've set up your Docker in your CI. All right, so this was a basic introduction, and for those of you who are already like using test containers, I wanted to add some stuff so you can get some ideas where test containers is heading to, and some things that are like maybe not optimal yet. So something you don't see in the code examples I've used, but you would see if you would write your own modules to test containers, is a self-typing approach we are using. So we are having kind of a fluent setter-like style. If you let's just quickly check in the code. All right, so we have here the Kafka, and here we can say like something like with, embedded with, something. So I can chain those stuff together. And since we can make subclasses of those containers, we are having the self-typing approach with a generic. Yeah, it's not super elegant maybe, and also doesn't play super nice with other JVM languages like Scala and Kotlin, for example. And yeah, new users, if they want to contribute a module or so, they regularly get confused by this approach, and also it's not super consistent with all modules. And yeah, we are thinking about different ways how we can solve this fluent pattern. And of course, there could be One way would be to have like a real builder and a builder pattern, or maybe even incorporate Lombok for this. But another cool idea we had was to just use double brace initialization. And we discussed this in the Slack, and it seemed like a good idea for us. But after like getting a bit of a feeling from the community, it seemed most people don't really like this. But I don't know, I'm showing this to you here, and what do you think about a API like this? Do you say like, oh, it's cool? Or if you see this, you will say like, I will never use test containers again if you ever implement this. So who likes this? Who hates this? Who doesn't care? All right. So of course, with this double brace initialization, I have learned you are not allowed to call it this way because this doesn't exist as a feature. It's just, as Brian Gertz says here, an accidental interaction of two actual features. But yeah, what is happening in this case is that you are creating anonymous classes, and of course you are polluting your JVM in this case, and that's something you would never, or you should never do in your production code. But I assume in the test code it would be fine. I don't know. All right. The other thing is having a way for real fast TDD workflows, especially if you are in a phase where you're experimenting against the system you are integrating with, like maybe writing some more complex SQL stuff or whatever. And if you follow one of those approaches I've shown, like basically just have test containers start up your external dependency, then you all the time get the startup overhead. And if this is 10 seconds, if this is 5 seconds, it really will get onto your nerves at one point if you really want to iterate really fast on your idea. But on the other hand, when like we think about test containers, we always think about that the test containers we are creating and starting should be ephemeral containers. So we're not sure yet how to marry these two approaches or these workflows, because you still want to avoid the actual test pollution for your integrate. Yeah, you don't want to have integrated tests there. Yeah, of course. And yeah, so not sure what we will do about this, because reusing containers is not easy to really give you a consistent experience that you don't reuse the wrong container suddenly. There are also possible features coming in Docker with container snapshots that would be super awesome, like that would be snapshots of a running container that you can instantly restore or nearly instantly restore. But this feature is also not going further that much, especially not on the desktop Docker versions like Docker for Mac and Docker for Windows. So let's see what we will come up here. All right, other stuff that's planned for the future. At one point, Test Containers 2.0, where we will think about this new builder pattern approach or whatever, and maybe have therefore an API breaking change. Then we are thinking about extracting a core library, a container core, we might call it, that's a complete test framework agnostic, and it's basically just an object-oriented abstraction over Docker containers, because we've seen people wanting to have this use case or using test containers for this use case, and therefore we should just like separate these concerns, having an instrumentation of Docker containers and having the test framework integration. Support for other languages, or maybe merging the concepts of the other languages, that will probably also come. And there's a really cool blog post from Oleg about using GraalVM to run JavaScript code or Node code that will then call into the Java implementation of test containers to start up the containers. It's super awesome. You should check this out. Maybe at one point support for Windows containers on Windows. Yeah. And I don't know, far future, and here I should have added a safe harbor statement, so it's just rough ideas, and it's also mostly ideas in my head, not necessarily from the team. And maybe support, again, Windows, but maybe support for orchestrators at one point, like Swarm, Kubernetes, or other container engines, or cloud IDEs, or whatever you can think of. Right, here are the resources. I will also publish the slides later on Twitter. And yeah, that's it. Thank you very much.